Hey students, in this video I'm going to show you how to solve one variable quadratic inequalities. An example of that is this right here, what you see. It is different from yesterday because yesterday we had inequalities that had two variables, x and y, so we could have graphed it. This one doesn't have x and y, so we're just going to approach it this way. We're going to look at the example given and we're going to make sure that if it was an equation, it will equal to 0. In this case, this one already does. And then we're going to solve the quadratic equation that you see right here. So there are different methods to doing that. The quickest method will be graphing it. So if we graph that quadratic, the graph will look like this. And if we solve for this quadratic, basically we're looking for the x-intercepts. So we trace and we look for the x-intercepts. One of them is at 2, 0, and the other one will be at -2, 0. So basically our two solutions are 2 and -2. We're going to interpret the solutions in three different ways: a number line, inequality notation, and interval notation. So a number line shows that we have the two solutions that the quadratic equation had. We write a circle in those numbers, -2 and 2 half circles, and then we either fill in or leave it open based on the inequality. So if the inequality is less than or equal to, greater than or equal to, it is filled in. If it's not equal to, then it's just open. When we decide where to draw arrows to, they could either go in different directions, and that just means any number less than -2 and any number greater than 2. Or we could have arrows that are going towards each other, so then that means the inside part is filled in. And we'll have an example like that right now. The other notation is inequality notations, which is this right here. So it's representing the same thing here, but just written with inequalities. So any number less than -2, that means x is less than or equal to -2. And then right here is any number greater than 2, including 2, so it's greater than or equal to 2. Then we have interval notation, which represents also this same scenario, but now we're looking at any number from -infinity to -2, and because we're including -2, we're going to have a bracket. And then over here is any number from 2 or greater, so from 2 to +infinity, and bracket again because it's including. So again, these will be with brackets, this will be with parentheses. So one example for that is this one. We want to start by equaling this to 0. So this -x, we add x to both sides. If there's like terms, we combine. If not, we just write it in order of standard. In this case, we are combining these two x's, so it gives you 3x minus 18 as the new quadratic. And now we're going to graph that quadratic to find the solutions. And you can use any method to solve algebraically if you prefer. But again, graphing is the quickest method. So after we type it in, we're going to find the x-intercepts. Menu and trace, graph trace. And if we go to the left, there is an x-intercept at -6. And then the other x-intercept will be at +3. So we can see that as -6 and +3. Those are the solutions. And then we can, from there, write a number line that has the two values representing the solutions at -6 and 3. This inequality symbol, it's not equal to, so we're going to leave these open. And then we need to decide whether to shade in between or shade in opposite directions. In between these numbers, the number 0 exists, so we can always plug in the number 0 for x and check if it will make a true or false statement. So what that would look like is 0 squared plus 2 times 0 minus 18. and then greater than negative x, so negative 0. So the simplest number to check is 0 because 0 squared is 0, so nothing, and then 2 times 0 is 0, so nothing, and then negative times 0 is 0, so nothing. So you end up with negative 18 greater than 0 as a statement. Is negative 18 greater than 0? The answer is no. So this will be a false statement, which means that the 0 is not a solution. So that confirms that we are shading outside of these numbers to the left and to the right. And then this would be a number line notation of the solution set. Following an interval or inequality notation, we're just going to say x is less than negative 6 or x is greater than 3. So it's just confirming what this is saying, less than, not equal to, and then anything before negative 6 and anything after 3. The interval notation will be saying anything from negative infinity to negative 6, and because it's not including negative 6, we're going to put parentheses. U representing the word or, and then parentheses 3 all the way to positive infinity, parentheses. So this is the interval notation for the solution set. All right, and the next problem we're going to have is this one. And this one, again, we start by equaling it to 0. So the 6x and the 4 need to cancel, so negative 6x and negative 4 will cancel those. Negative 6x and negative 4. And then we combine like terms, so these are like terms and these are like terms. So we're going to have x squared minus 1x minus 6. That's the quadratic equation that we're going to graph and solve for. So let me just type that. X squared minus 1x minus 6. And the intercepts will be negative 2 and positive 3. So we have negative 2 and positive 3. So our solutions of negative 2 and positive 3 are the numbers we're going to use. And we're going to draw a circle. This inequality sign is equal to, so we fill it in. And then the 0 is in between the numbers, so let's check if 0 is the solution. We plug in a 0 in for each part, so 0 squared plus 5 times 0 minus 2 less than or equal to 6 times 0 plus 4. And once again, 0 squared is nothing, 5 times 0 is nothing, 6 times 0 is nothing. So you're left with a statement of is negative 2 less than or equal to 4? Negative 2 is less than 4, so yes, this is true. And because it's true, that means this is a solution. So we shade in between these two. This is the number line interpretation of the solution. And from there, we're going to write the inequality notation, which means that you have any x value between negative 2 and 3. So you're going to write this notation like this. And then the interval notation will be bracket negative 2 comma 3. And this is just saying any value from negative 2 to 3 and bracket because it's shaded in. So it's including negative 2 and 3. Okay, I hope these two examples help you understand solving inequalities.